Foucault pendulums are placed in different parts of the world, and during the day, the pendulum seems to be rotating. So, we're going to understand why this phenomena actually happens. In this video, we will understand the principle of Foucault pendulum. Foucault pendulum is just an ordinary pendulum. When you swing any pendulum, it keeps swinging in the same direction unless you push or pull it into some other direction. However, the earth beneath it rotates periodically. How much does the earth rotates? It all depends upon the latitude where you place the pendulum on the earth. And on the northern hemisphere, the pendulum seems to be rotating clockwise. Apparently, the earth beneath it rotates anticlockwise. On the southern hemisphere, the pendulum seems to be rotating anticlockwise. Apparently, the earth beneath it rotates clockwise. On the equator, the pendulum don't seems to be rotating because the earth beneath it do not rotates on the equator. And why the earth rotation depends on the latitude, that we are going to see in this video. What we see is there are three persons here. One directly on the North Pole, and one is on the equator, and one guy in the South Pole. Alright. What we see here is that each one of them is holding a flag on their right hand. And we have also marked the front and back of them. Let's see what we observe. We do observe that when this earth rotates in this direction, and if you look at from the top of it, it looks like it is rotating. Which direction sure it is rotating?
Counterclockwise.
Counterclockwise. And let's keep spinning this way and take this camera down, down, and see what direction is this now. What direction is this now?
Clockwise.
Clockwise. So your observation is right. On the North Pole, it seems to be rotating counterclockwise. On the South Pole, it seems to be rotating clockwise. Let's make some other observations as well. If you look at a person on the North Pole, you see its front and then back. And of course, in his right hand, he is holding a flag. You see the right hand in front of you and then left hand in front of you as well. But if you look at the person on the equator and you imagine that this earth is transparent, you will never see its back and front rotating. Look, you definitely see its left hand in front of you and then right hand in front of you, but from an independent observer in the space, will never see that he is rotating on his back. Correct? Imagine this as a transparent globe. Look at it and surely tell me, do you see its back rotating as the way it's rotating on the North Pole? Now you see its front, and if this earth keeps spinning, you see its back.
Yes.
Yes. Do you see the similar behavior in its front and its back for the person standing on equator? You always see, look at this, right?
Yes.
You always see that it's not rotating, it's back and front. Okay, look, right? But the same thing happens with this person standing on the South Pole. You do see its front, and sometime back you see its back, and then front, and then back. But as far as the hands are concerned, you see that all the three persons, sometimes they face right hand in front of you, and sometimes they face left hand in front of you. Right? So end of these observations. So now, as we saw our observations, we saw that on the North Pole, the Earth is rotating. Which direction shall I?
Counterclockwise.
Counterclockwise. Let's mark it as a positive one. that this direction is positive one. So on the south pole, it is rotating clockwise. So then let's mark it a negative one. So it's quite intuitive that between this positive one and negative one, there is a zero. So what point that zero should be shown?
Equator.
Equator. So what this means, positive one, negative one, and zero, means that this is a spin of back, or let's say rotational motion. This guy is spinning its back. And what direction? Positive one. The guy on the south pole is also spinning its front and back, and that is, we have marked that as a negative one. And this guy on the equator, we marked as a zero, that it is not spinning its front and back. So let's see that on the paper.
Okay.
Now we see these numbers on a paper. On equator, we have marked as a 0. On the north pole, we have marked as a positive 1. That means this spin is counterclockwise. And on the south pole, we have marked this number as a negative 1. That means clockwise rotation. So it's quite intuitive that definitely should be no rotation, that there should be a 0 in between, and that is the equator point here. So to make it simple, I have put it as a linear formula, but it is not a linear formula. To find out that how many degrees Earth rotate in 24 hours, it's the exact formula is sine of x multiplied by 360. This x is latitudes where you live on the earth. So you find out your latitudes on the earth, put that latitude in x and multiply that number with 360. You will find out that how much rotation do you make in a day on that point. So on equator, sine of 0. So on equator, sine of 0 is 0, because on equator latitude is 0. So you don't spin at all on equator. But on the poles, on the 90 degree, you put this latitude as 90 degree, you get one number. Sine of 90 is equal to 1 multiplied by 360. So in a day, you rotate 360 degrees. On the south pole, you also has a negative, you also have a 90 degrees, but that is a negative direction. So you put sine of 90, which is also 1 multiplied by minus 1 multiplied by 360. So you get 360 degrees, the other direction rotation, where from the direction that you get on the north pole. So that's it. So now we'll understand that how the Foucault pendulum works. So Foucault pendulum is a pendulum which is not special, but it is allowed to rotate freely on its axis, and it will act like a free observer, an independent observer, like we did it in our last video. We were observing the earth, and while earth was spinning. So while the earth was spinning, but we were not. We were sitting there outside in the space, and we were simply sitting there, and while earth was rotating to us. And if someone is sitting on earth, to them we will look like that we are rotating, but that's not the case, right? Actually the earth is rotating and we are stand still over there. Similarly, this pendulum is not rotating, but earth rotates. But but it looks like, since the earth is rotating anti-clockwise in northern hemisphere, so it looks like the pendulum is rotating clockwise in the northern hemisphere. And how much in the degrees? So that depends upon where this pendulum is located. So if this pendulum is located in, let's say, Tellus Science Museum, which is at altitude of 34 degrees, and sine of 34 degree multiplied by 360 is 201 degree. So it will look like that this pendulum is rotating clockwise in the Tellus Science Museum in Georgia by 201 degrees in a day. So there are some dominoes or some stuff that is located in the on the circular path, and as the pendulum rotates, it strikes them, and those little pieces of wood, they fell down. In a day it rotates 201 degree. Actually don't rotates, but the earth beneath it rotates, and that makes them fall. And how much rotation? 201 degree in a day. Similarly, in Paris, This pendulum rotates 271 degrees because it is located at 48.86 altitude. And Stockholm, the altitude is 59.32. So in a day, it will rotate 309.6 degrees. And if you talk about equator, and if you put the same pendulum on the equator and put all those small pieces around it, it will not drop any of them, because it won't drop anything, because sine of 0 is 0 multiplied by 360 is again 0. So in a day, the rotation of that pendulum will be 0. So it will keep exactly swinging in the same direction. Okay. Similarly, if you put the same pendulum in the southern hemisphere, that's in Australia, so it will drop the it will hit them, the pieces, but in the southern hemisphere, in Australia, it will hit them in the counterclockwise direction, because earth is spinning clockwise direction over there. हाँ
ये लाइन है
हाँ
और ये पेंडुलम है पेंसिल। तो अगर अर्थ रोटेट नहीं कर रही तो पेंडुलम की लाइन इस तरीके से इस पे बन गई। अब हमारी अर्थ रोटेट कर रही है काउंटर क्लॉकवाइज, तो अब हम देखते हैं पेंडुलम की
और
लाइन
पेंडुलम तो वैसे ही घूमता रहेगा जिस डायरेक्शन में जा रहा था, स्विंगिंग। ठीक है। हाँ बस।
और इससे हमें पता चला कि हमारी लाइन बन रही है क्लॉकवाइज।
क्यों क्लॉकवाइज बन रही हैं? क्योंकि पहली लाइन तो यहाँ थी और अब जो है हमारी लाइनें यूँ बनती जा रही हैं, विच इज़ क्लॉकवाइज डायरेक्शन। एंड विच डायरेक्शन डिड यू रोटेट?
काउंटर क्लॉकवाइज।
काउंटर क्लॉकवाइज।
The ball represents the earth. This pencil will be represented as a pendulum, and this is the north pole, this is the south pole, and the string is the equator. Now we will demonstrate how the pendulum works on the North Pole. So the pendulum seems to be rotating, but it is always moving in a straight line, and it is the earth that is rotating, which causes it to seem like it is rotating.
Correct. And what happens on the equator?
On the equator, its rotation is 90 degrees, which can be observed as you can keep on rotating the earth, and the pendulum is always moving in a straight line.
So this pendulum is actually not rotating at all.
Yes, and on the bottom, which is the south pole, the same thing happened in the north pole.